Hello AP Stat students, welcome back. This video I wanted to take the opportunity to kind of briefly review all of chapter 10, and then also I wanted to give you some heads up as to what will be on the exam and some tips and tricks for taking the chapter 10 test. Okay, so let's get into this. I want to try to make it as brief as possible. So all of chapter 10 was about confidence intervals, and confidence intervals take this general form. So we use a point estimate. Okay, so point estimate, and we get that from a set of data or a sample of some sort, hopefully random, and then we add or subtract this margin of error. Okay, and the margin of error is either a critical z value or it's a critical t value times a standard error. Okay, so what we do is we take this point estimate and um, we add this margin of error. Okay, so we add it, and then we also subtract this margin of error, and it gives us this interval that hopefully will capture a population parameter. Okay, so whether that be, say, a population mean or a population proportion, hopefully this interval will capture that, so it will give us a rough estimate as to where our population parameter will fall. Okay, so we talked about three different types of confidence intervals. So I want to go over each one and kind of what you need for each type of interval, and how to tell which type of interval you should be using. Okay, so let's start off with a one sample z interval. So if I'm performing a one sample z interval, I need to know the population standard deviation. Okay, so one sample z interval. And the big thing here is that in order to use this, we have to know the population standard deviation. So the population standard deviation is known. It's given to you in the problem, okay? So when we're performing this test, like I said, on the AP exam, you can either simply write the name of the test, in this case it's an interval, or you can give the formula for this interval. So you can write on your paper x bar plus or minus critical z times this population standard deviation divided by n. Okay? No matter whether you have the name of the interval only or the formula of the interval only, they do want to see you writing what each variable in the equation is representing. Okay, so for instance, then I would go ahead and I would write x bar equals, whatever, 3. And then standard deviation of the population equals, say, 2. And then what is my critical z value? And then how big is my sample size? Okay, now keep in mind that for our critical z values, let's talk about that real quick. These are always going to be positive. Always, always positive. And that's for critical t as well. So these critical values are always positive. And when you find them, you can get the common ones memorized. So most of the time we're going to be dealing with a 90% confidence interval that has a critical z of 1.64, or a 95% confidence interval that has a critical z value of 1.96, or a 99% confidence interval that has a critical z value of 2.56. Okay, So that might be easy for you to get memorized if you've got some extra space in your brain. Or what you can also do is you can do an inverse norm, and you can find that critical t value for the type of interval you're trying to construct. Okay? Remember that the area that you would want to use when you're performing that inverse norm operation on your calculator, you would set the area to half of the difference between the confidence level and 1. Okay? So like 100% minus 90% makes 10%, and then cut that in half, so that is 0.05. Okay? Or say half of 5% would make the area 0.025 for a 95% confidence interval, and then the area for a 99 would be 0.005. It'd be half of 1%, okay? So if you're doing inverse norm, make sure that you're looking at the area of just one of those tails, all right? Now, let's talk about real quickly here the conditions required. So number 1, SRS. 2, 10% rule. Okay, so that's your n is greater than or equal to 10n. And then 3, your normality condition. So for population means, you are looking to see if your sample size is greater than or equal to 30. And then if it is, you say by CLT, by the central limit theorem, it's safe to assume normality, okay? But if your sample size is not bigger than or equal to 30, say for instance, you had a sample of 10, okay? So what you would do there, whoops, I did not mean to put that equal sign there. What you would do then is graph it. You need to graph it. So you don't need a super detailed graph, but you do need a graph on your paper, and the easiest types of graphs to make are box plots, okay? So I might put my graph here showing that, hey, that graph looks, approximately symmetric. It's not heavily skewed right or left. I'm also looking for outliers. I don't see any, so it's safe to assume normality, okay? Now, if, for instance, your graphs, say, looked like this, where it was sort of obvious that it had this really long tail to the right, then you would make a note. You would go ahead and proceed on with the rest of the conditions, calculations, and conclusion. But in your conclusion then, after you interpret the interval, you would want to make a statement saying that, the normal condition wasn't actually met, and therefore we should not really be generalizing these conclusions to the entire population, because we don't know for sure that this sampling distribution is normal, okay? Let's go on to discuss our one sample t intervals. So the big difference between a one sample z interval and a one sample t interval is that we use a t interval when we do not know the population standard deviation. So population standard deviation is unknown. Okay? So it's known for a z interval, it's unknown for a t interval. So our formula then varies slightly. It is x bar plus or minus critical t times the sample standard deviation divided by the square root of n. Okay? So this right here is the sample standard deviation instead of the population standard deviation. And that is something that would be either A, given to you in a problem. They said we took a random sample and we got a mean of X bar and we got a sample standard deviation of, S of X. So when you are using this interval, you can either A, you can give the name of it, so you can just simply write on your paper one sample t interval, or you can write the formula, okay, or you can do both, that's even better, but no matter what, you need to write down the value of each of these variables for the formula. So I want to see on your paper the value of X bar, okay, and then the value of your standard deviation, okay, and then the value of n. Now, before you write critical T down, what you need to do is find the degrees of freedom, okay? That has to be written on your paper. If you don't include it, it is at most a partial credit on the AP exam, okay? So degrees of freedom are required in order to find critical T. So you have to find that first, and then you can find your critical T value, okay? Now, in order to find that critical T value, you can either use an inverse T or you can use the table, okay? And the table will be provided for you on the exam. So whatever you feel more comfortable with there, all right? Let's talk just quickly about the conditions. They are the same for a one sample Z interval, so SRS, 10% rule, population is bigger than or equal to 10 times sample size. And then our third condition, normality, and that is n is greater than or equal to 30. So remember, if the sample size is not greater than or equal to 30, then you need to graph the data, graph it if n is less than 30, make a box plot on your paper, and then summarize, hey, the graph for the distribution of my sample does not appear to be heavily skewed one way or another, and it doesn't have outliers, so it's safe to assume normality, okay? All right, so I want to actually talk about sort of a branch of this one sample T interval. We call it a paired T interval. Now, this paired T interval is really just a one sample T interval. And that means it's basically going to follow all of the rules of the one sample T interval, with just a few exceptions to how we state the parameter, how we carry the test out, and then how we state our conclusion, okay? So we use a one sample T interval whenever we have like a matched pairs design. Okay, so there is a very good example in our note-taking guide, the caffeine experiment, if you remember that experiment. So we had a matched pairs design. And that matched pairs design, what we were doing is we were taking subjects that were caffeine dependent and we were giving them in alternating order. We were giving them either a placebo, so fake caffeine, or we were giving them their caffeine. And then we were comparing one individual to itself only, okay? So each person was getting two treatments. We were doing it in alternating order. And we were seeing if there was any difference, okay? So that's the biggest thing here is we're looking at a difference. So when you do a matched pairs design, what you want to do is you're going to have two sets of data. You want to reduce the two sets of data down to one set of data by taking a difference, okay? So what you would do is you would take, say, your list of data from the subjects who received the placebo, and then you'd plug them into list 1. And then you would take your list of data that represents the subjects receiving the caffeine, and you would plug that into list 2. And then you would define this third list as your difference list, okay? And it doesn't matter which order you subtract the lists, but you need to write that down on your paper, okay? And by the way, this is just very general. Please do not be talking about lists on your free response question. I'm just simply going over how one would carry this out on their calculator. So for list 3, we would say list 3 is going to be, say, for instance, list 1 minus list 2. Okay, so I'm defining my difference there. All right, so then when we set up our test, what we're doing is I'm taking 2 sets of data and I'm subtracting them to reduce it down to 1 set of data, and that's how it becomes this one sample t interval, is because I take 2 sets of data and subtract them and turn it into 1 set of data. Now, like I said, there's a slight difference in the way that we define the parameter and state our conclusion. Since we are subtracting, what we want to do in our 4-step process, for step number 1, we want to say let mu equal the true mean difference of our parameter, okay? Because we're subtracting, and so we're not talking about the true mean, but we're talking about the true mean difference. After we've subtracted all of the possible samples, this is what we would get on average. And then step number 4 here, when we go to interpret our confidence interval or make our final conclusion, what we want to say is we want to refer back to that parameter we defined in step number 1. So we want to say we can estimate, with, say, 95% confidence that the true mean difference. So we can estimate with 95% confidence that the true mean difference in, whatever, in the placebo minus caffeine, or, whatever you're talking about, okay? So make sure that you say true mean difference in a paired t interval. Otherwise, your conclusion will be set up for just a 1 sample t interval, and you could lose credit on that, okay? All right, let's go on to talk about our last type of interval, which is the 1 prop z interval. So our 1 prop or 1 proportion z interval is only used for proportions, okay? So if we're talking about a part over a total, like, say, for instance, I flip a coin, say 80 times, and I'm looking at the number of heads I get, okay? So we're going to be talking about proportions or percents, and that's when we use a 1 prop z interval. And the formula is p hat plus or minus our critical z times the square root of p hat times 1 minus p hat divided by n, okay? Now, remember, when you are executing this, you can give the name of the test, or you can give the formula, or you can do both. But you have to have one or the other. And then I also want to see that you have defined each one of these variables required in your formula, okay? Now, remember that for proportions, we only use z procedures, okay? You will never use any sort of t procedure when you are executing problems talking about a proportion or a percent here. So always use a Z procedure for proportions. Okay, and like I said, for our critical Z value, you can get them memorized or you can do an inverse norm on that. Let's talk about the conditions here real quick. Number one, SRS, same as one sample, Z and T intervals. Number two, 10% rule, that's the same as well. Our population greater than or equal to 10 times our sample size. The third condition is different here. So for normality, we need to show that n times p hat is greater than or equal to 10 and n times 1 minus p hat is greater than or equal to 10. Okay? So, yeah. All right. So, this is your successes, right? And then this is our failures, the number of failures. So we either do have enough successes and failures to assume normality, or we don't have enough successes and failures to assume normality. When we check condition 3 here, if this condition is not met, like say for instance our successes are not greater than or equal to 10, there's no way to graph the data. So there's no way to get around this specific condition like there was a way, to get around if our normal condition wasn't being satisfied for a one sample T interval, we could graph the data, but we cannot graph the data for the normal condition if we're talking about proportions. Okay, we can't do that. So we would just go ahead and proceed through the interval calculations and comment about the interval and then make a comment about that condition not being met and how it affects our conclusion. Okay. All right, so with that, I just kind of gave you just sort of a brief overview of each type of interval. What I want to talk about is the free response questions. Okay, so on the exam, there will be 3 free response questions. So 3 total. Okay, you should be comfortable with the 4 types of intervals that we just reviewed. Okay, so one of the problems is going to be a one sample, we'll say Z interval or T interval. Okay, so you're going to need to be able to look at the problem and first identify that we're talking about a population mean. Okay, and then you're going to need to be able to determine, do we know the population standard deviation or do we not know that? And that then will lead you to which type of interval you need to be using. The second problem, it might not be, number 2 on the exam, but the second type of problem that you're going to see on the free response portion is a paired T interval. Now, this is just a one sample T interval, okay? So really, it's just a one sample T interval. But the biggest thing is the process involved, how we have to take 2 sets of data from a matched pairs design and reduce it to one set of data in order to perform that interval and calculate it. Okay, so what I would suggest is looking over your caffeine problem in your note-taking packet and make sure that you feel comfortable with those steps. And then the third type, obviously, is our last one we talked about, our one prop z-interval. And all of these are going to require the four-step process. So what that means is you, 1, state your parameter. 2, check your 3 conditions. 3, make your calculations. So state the name of the interval by its proper name or write its proper formula. And then make sure that you have all of the values of your statistics there. And then compute the interval correctly. And then step 4 is to correctly interpret the interval. Okay? Now, let's talk about multiple choice. What might be on the multiple choice part? So, what you need to be able to do for the multiple choice is correctly interpret an interval in context. So, interpret a confidence interval in context. Okay? And then also, you need to be able to interpret the level of the confidence interval in context. So interpret level, and I'm going to underline that, interpret level of confidence interval in context. Okay, so that is different than interpreting the interval itself. Okay, so if I was interpreting the interval itself, I would say something like, we can estimate with 90% confidence that the average score of the Chapter 10 test for AP statistics will fall between 50% and 95%. Okay? That's just an example. So interpreting the interval in context versus the level, I would say in 95% of all possible samples of, say, size 10, will yield an interval that captures the true population parameter. Okay, so there is a difference in those. We talked about this in our note-taking guide in class, and there's also some examples in that note-taking guide, so you might want to look that over. Okay. Also, you should be pretty familiar with the confidence interval, just computing it. Like, I might ask you to find, like, say I might give you an interval with some information, like, say, I don't know, some interval that goes from 2 to 10. I'm just making this up. And I might give you some information, like, say, I might tell you that the margin of error is equal to, I don't know, some number, okay, say X. And then I might ask you to find the point estimate, okay? So I might ask you to find X bar for me, okay? So you should be able to work with that confidence interval or properties of that confidence interval. Okay, so remember, it's this critical value, or we call it a point estimate. Our point estimate plus or minus our margin of error. Okay, so we can kind of work backwards and work through that. You should be able to find critical T and critical Z for me. Okay, you should be able to tell me what makes a confidence interval wider or shorter. So what makes a confidence interval wider or shorter? Okay, so that's things like the confidence level as well as sample size. And then lastly, you should be able to solve for n, which is the sample size, to achieve a desired margin of error. Okay, so what I mean by that is let's go back here and look at for starters, our one sample z interval. Okay, so I might tell you I want to reduce the margin of error to, say, 2. Okay, I don't want it more than 2. So that means this is our margin of error. So you would say, I do not want this part of my formula to be greater than or 2. Okay, so then I find critical z, and I find my population standard deviation, and then I solve for n to determine my sample size, and we always round up. Remember, always round up, because bigger sample sizes will ensure a smaller variability. Okay. If it's a t interval and I'm asking you to find me that sample size to achieve this certain margin of error, what you do is you have to actually use a z interval. Okay, so you solve it, just like this last problem, but sometimes we'll actually input this value as like the sample standard deviation, but there's no way we can find critical t without knowing the sample size, because remember that you have to have degrees of freedom to find critical t, and if we don't know sample size, we can't find degrees of freedom, which means we can't find critical t, so we must use that z procedure. Okay, so then lastly, if we're talking about a population proportion and I ask you to find a certain sample size to achieve a desired margin of error, you're taking this bit of the formula and you are setting that equal to a specific margin of error. Okay, so let me just write this out real quick. So we have our formula here, and let's say I don't want my margin of error to be no more than, say, I don't know, 0.5. Okay, so if we're solving for n, which is sample size, we have to have sample size in order to find our sample proportion. So what we do is we assume that p hat is equal to 50%. This is an assumption that we have to make in order to solve for that sample size. Okay, so we assume that there's no difference in the number of successes and failures, and then we go ahead and plug that in after we found our critical z value, and then we solve for n. Okay, all right, so I think that kind of wraps it up. I hope this was helpful for you. The Chapter 10 review problems should be completed and graded, and those are, remember, the answer key is online in the Chapter 10 folder. Those problems should give you a very good opportunity to practice for your free response questions. And if you haven't already started the practice test, I really encourage everyone to do that. And also, it doesn't hurt to crack open your textbook and practice a couple homework problems if things just aren't clicking for you. Other than that, I wish you good luck on your Chapter 10 test, and stay tuned for the next video when we jump into Chapter 11. I hope you all have a great day, and we'll see you next time.